welcome to the Bare Metal Cyber CISSP Prepcast. This series helps you prepare for the ISC Squared CISSP exam with focused explanations and practical context. In this episode, we explore two essential cybersecurity concepts: distributed denial of service, or DDoS protection, and the design of high-availability networks. These areas are critical for any organization aiming to maintain business continuity, especially in the face of increasing cyber threats and growing dependency on always available online services. We'll begin by examining the nature and objectives of distributed denial of service attacks. A DDoS attack seeks to disrupt the normal operations of a network, service, or server by overwhelming it with a flood of illegitimate traffic. The goal is to consume all available resources, whether that's bandwidth, memory, or processing capacity, thereby making the system unavailable to its intended users. Attackers often use botnets, a large number of compromised systems, to generate massive traffic volumes. These attacks can come in different forms. Volumetric attacks aim to exhaust bandwidth. Application layer attacks target specific services like web servers, making them slow or unresponsive. Protocol attacks, such as SYN floods or ping of death, exploit weaknesses in network protocols to crash systems or overload infrastructure components. DDoS attacks are not just a nuisance. They can cause revenue loss, reputational damage, and breaches of contractual service-level agreements. Organizations in sectors such as finance, healthcare, e-commerce, and government are especially vulnerable due to their reliance on constant uptime and user accessibility. Now let's move into techniques for protecting against DDoS attacks. One of the most effective first steps is traffic filtering. Firewalls, intrusion prevention systems, and access control lists can be configured to block known malicious IP addresses or abnormal packet types. Rate limiting is another technique that limits the number of requests a single source can make within a certain period, helping prevent overload from a single actor. DDoS mitigation services play a vital role as well. These services often involve cloud-based scrubbing centers that inspect incoming traffic in real time. Malicious traffic is dropped or filtered out, while clean traffic is forwarded to the organization. Many content delivery networks, or CDNs, offer built-in DDoS protection by dispersing traffic loads and filtering at edge locations. To add resilience, organizations should also configure redundant systems and failover infrastructure. If one data center or network segment becomes overwhelmed, others can continue providing service. Automated responses and pre-configured incident playbooks allow teams to detect, mitigate, and recover quickly from attacks. Next, let's shift to the concept of high availability, often abbreviated as HA. High availability refers to a system's ability to remain operational and accessible for as close to 100% of the time as possible. It's not about eliminating failures, it's about designing systems to survive them. High availability networks are built on four core principles: redundancy, load balancing, fault tolerance, and automatic failover. Redundancy ensures that if one component fails, another can take over. Load balancing distributes user traffic across multiple servers, avoiding overload. Fault tolerance involves systems that can detect failures and continue running without interruption. And automatic failover allows traffic or workloads to shift instantly to backup systems. A practical example would be a website hosted across multiple cloud regions. If the primary region experiences a power failure or attack, the secondary region automatically takes over. The user may never even notice the transition. In regulated industries such as banking or healthcare, maintaining high availability is not only good business practice, it's often a compliance requirement. It also helps meet customer expectations, prevents data loss, and supports operational resilience in the face of cyber attacks or system errors. Let's take a short break to connect you with more resources. For more information on CISSP certification and other valuable cybersecurity training tools, visit cyberauthor.me. You'll find best-selling books, downloadable tools, and structured guidance tailored for security professionals at every stage of certification and career development. Now let's walk through the steps for designing high-availability networks. First, implement redundant network components. This includes routers, switches, servers, storage arrays, and even entire data centers. Avoid single points of failure by duplicating critical systems. Next, use load balancers to distribute traffic across multiple servers or services. Load balancers not only prevent overload, but also monitor system health and automatically redirect traffic if one system fails. Automatic failover is another must-have. This requires systems to detect when something goes wrong and immediately shift operations to a healthy backup. For example, database clusters can be set up so that if the master node fails, a replica is automatically promoted. Geographic redundancy is also important. Hosting applications in multiple physical or cloud locations ensures continuity even during regional outages, natural disasters, or localized cyber attacks. It's not enough to design these features, you must test them. Regularly simulate failure scenarios to ensure failover mechanisms work as intended. Include tabletop exercises and full-scale simulations to prepare technical staff, business leaders, and third-party vendors for real-world incidents. As you prepare for the CISSP exam, remember that DDoS protection and high availability go hand in hand. One defends against intentional disruptions, the other ensures business can continue even if defenses are bypassed or infrastructure fails. Let's now talk about implementation best practices. Your organization should document all configurations and policies related to DDoS protection and high availability. This includes device settings, failover plans, escalation procedures, and contacts for DDoS mitigation providers. Regular updates and reviews are necessary. Technologies evolve, and so do attack techniques. Update your firewall rules, DNS configurations, and cloud routing tables regularly. Review your provider agreements to ensure sufficient bandwidth and mitigation capabilities are in place. Comprehensive monitoring is essential. Use tools such as flow analysis, real-time traffic inspection, and behavioral anomaly detection. These tools not only detect attacks, but also help identify early warning signs of system degradation or resource exhaustion. Train your teams to recognize and respond to both DDoS attacks and system failures. Incident response procedures should include technical recovery, customer communication, legal review, and root cause analysis. Don't wait for a real attack to test your team's readiness. Let's turn to exam-focused tips. On the CISSP exam, expect questions that test your understanding of network availability and resiliency. You may see scenarios where systems are failing, and you'll need to identify the right high-availability strategy. Or you might be asked to choose the best DDoS mitigation approach for a given business use case. Make sure you can differentiate between concepts like redundancy, fault tolerance, and disaster recovery. Also understand technologies such as content delivery networks, scrubbing centers, load balancers, and geographic replication. These terms may appear in questions that require application, not just memorization. Finally, let's talk about continuous improvement. Resilient network infrastructure is never set it and forget it. You must continuously evaluate and adapt your DDoS and high availability strategies. Conduct post-incident reviews, even if an attack was mitigated. Look for root causes, secondary impacts, and opportunities to automate or improve processes. Work cross-functionally. Security, networking, DevOps, legal, and business continuity teams must all collaborate. Alignment across disciplines ensures that high availability and DDoS protection are embedded in both design and response strategies. Keep your teams informed. As new tools and threats emerge, your staff must stay ahead. Provide ongoing training, simulate incidents, and reward proactive improvements. Culture is just as important as technology when building resilient networks. In conclusion, defending against distributed denial of service attacks and designing high availability networks are two of the most critical practices for modern security professionals. Together, they ensure your organization can continue delivering services securely, even under the most stressful and unexpected circumstances. Thanks for joining us for this episode of the Bare Metal Cyber CISSP Prepcast. For more episodes, tools, and study support, visit us at baremetalcyber.com.